So now we are starting with question number 8. Question number 8 is XY is a line parallel to side BC of a triangle ABC. If BE is parallel to AC and CF is parallel to AB, meet XY at E and F respectively. Show that area of triangle ABE is equals to area of triangle ACF. Okay, now the figure is given to you and all the description of the figure is given to you in your question. That is, first is XY is a line, okay, which is parallel to side BC of a triangle ABC. First is, in this figure we are having a triangle, that is triangle AB and C. Then XY is a line which is parallel to this triangle. Okay, then after BE is parallel to AC. Okay, so for making BE we are making it here, that is parallel to AC. So here is your BE which is parallel to AC, and CF, F point is over here, which is parallel to, that means this way your one line will come. CF is parallel to AB. Okay, then after that is meeting XY at E and F respectively. Okay, so they are meeting and this way. Okay, now this is your figure. Now it is given that from this figure you will observe that it is given that XY is parallel to BC. Okay, XY is parallel to BC and EY is also parallel to BC. XY parallel to BC over here, and EY is again parallel to BC. Okay, that means both are parallel to BC only. Now BE is parallel to AC. Now again observe clearly. So BE is parallel to AC and CF is parallel to AB. Okay, BE is parallel to AC, so CF is also parallel to AB. Okay, now if BE is parallel to AC, observe clearly. If BE is parallel to AC, so can I write BE is also parallel to CY? That means this small portion is also parallel. Okay, so we can write, if BE is parallel to AC, that means BE is also parallel to CY. So if the opposite side of one quadrilateral is parallel, then we can say that EBCY is a parallelogram. Now again same reasons. See, XY is parallel to BC. Here again XY is parallel to BC, and XF, if we will watch, the whole XF is again parallel to BC. Okay, so can we write BX or AB which is parallel to CF, this and this. Okay, if the whole is parallel, so can I write the part is also parallel? So here I can write that XB is again parallel to CF, because if AB is the whole, so part of it will be also parallel. So we can write FC parallel to AB and FC is parallel to XB. Okay, now again you had proved that opposite side of this is parallel. So the given figure is again a figure of a parallelogram. So BCFX is a parallelogram. Now you know that if two parallelograms are on the same base and between the same parallels, okay, then they are equal in areas. Now which two parallelograms? So parallelogram EBCY. Let me highlight the parallelograms. So first is parallelogram EBCY, this parallelogram, and second is parallelogram BCFX. Okay, so these two parallelograms are on the same base, that is BC, and between the same parallel, that is BC and E2F. Okay, these are two parallelograms, so they will be equal in areas. So area of EBCY will be equals to area of BCFX. They are equal in areas. Now consider parallelogram EBCY and triangle AEB. Now if we will consider a parallelogram EBCY, let me highlight the parallelogram EBCY and the triangle ABC. So triangle ABC we are highlighting. Okay, now if we will consider these two triangles, so again this line on the same base, that is BE, is the same base for this, and between the same sets of parallel line, that is BE and AC. Okay, so they are lying between the same sets of parallel lines and between the same base. So we can write that area of triangle is equals to half of area of parallelogram, and again we can do same thing on the other side also. That means for BCFX. Okay, so again same thing on the other side. Area of triangle ACF is equals to half of area of triangle BCFX. Same thing we had done, which we had done over here, same we had done over here also. Give this as result number 3. Now if we will observe result number 1, result number 2 and result number 3. So area of EBCY and area of BCFX, both parallelogram are equal in area. But area of ABE is half of EBCY and area of ACF is half of BCFX. Okay, so if both are equal in area, so can we write area of triangle ABE is equals to area of triangle ACF? Because if the areas will be equal, then these values will be also equal, and if these values will be equal, then the values on the left hand side will be also equal. Okay, so we can write directly that from equation number 1, 2 and 3, areas of ABE will be equals to area of ACF. Now come to question number 9. Question number 9 is the side of a parallelogram ABCD is produced to any point P. Okay, parallelogram ABCD is there and that side is produced to any point, that is point P. Let me draw the figure along with this question so that you will understand. Okay, ABCD is a parallelogram. A, B, C and D. Then after P is produced to any point P. Now in parallelogram ABCD, AB is produced to any point P. So we are extending AB and it is producing point P. Now a line through A. We have to take a line through A and parallel to CP. Okay, a line which will be parallel to CP. So we have to join CP first. Then meets CB produced at Q. That line is meeting CB, which is producing a point Q further. Okay, so now we are joining this also. Then parallelogram PBQR. Then you have to draw a parallelogram PBQR. So how you will draw a parallelogram PBQR? So, oh sorry, you don't have to join this. Okay, now see, here you are having CB produced at Q and then parallelogram PBQR. So here P point is there. So P we are taking over here and this way we are making a parallelogram PBQR. Now parallelogram PBQR is completed. Now see the following figure, you are having this figure. Now hint is given to you, join AC and PQ. Okay, so join AC, A to C. I am joining it with other color, A to C, and next is we have to join P to Q. Now you have to join P to Q. Okay, now compare area of ACQ and APQ. Then after we have to compare the areas of ACQ and APQ. Now to make this figure complete, we have to join this with AQ. Okay, so now you are having the complete figure. Now in this figure you want area of ABCD is equals to area of PBQR. ABCD we have to prove that it is equals to area of PBQR. Okay, so how we will prove? So first of all, whatever we had constructed you have to write that. So let us join AC and PQ. Okay, we had joined AC and PQ. Then if you will observe clearly, then you can see ACQ, triangle ACQ if you will observe. Okay, this triangle ACQ, let me highlight it nicely. ACQ, if you will observe this triangle and triangle APQ, I am highlighting it with other color. Okay, these are on the same base, that is same base for this ACQ, and APQ will be AQ. Okay, common base between these two, and they are between the same sets of parallel line, that is AQ and CP. So both these two triangles will have equal area. So area of ACQ will be equals to area of APQ. Then after, if you will again observe, if you want ABC, then how you will get? So here you can subtract. So area of triangle ACQ, let me rub this out. See, area of triangle ACQ minus ABQ. Okay, here we are having ACQ. Let me highlight this again. ACQ is this whole triangle ACQ. Okay, and in this triangle now we will subtract ABQ. So I am highlighting it with other color, ABQ. So you will get ABC. Then after, again for other thing, so now when you will subtract this from that triangle, that is from triangle ACQ, when you will subtract triangle ABQ, then after you will get triangle ABC. Then same way on the other side. Then on the other side, when you will subtract area of triangle APQ, let me highlight the triangle for you. APQ is this triangle, minus when you will do ABQ, let me highlight with other color. So ABQ, this much of triangle, then you will get area of triangle QPB, that is this triangle. Okay, so area of triangle ABC will be equals to area of triangle QPB in this way. Then after, when both these two triangles are equal, okay, now see, area of triangle ABC is equals to area of triangle PBQ. Okay, so both these two triangles are between the same parallel, that is AC and PQ. Okay, so we can say that since AC and PQ are diagonals of parallelogram ABCD and PBQ are respectively, so we can write, say diagonals divide the parallelogram into half. So we can write area of ABC is equals to half of ABCD. Again same way for area of QBP is equals to half of area of PBQR. Okay, now from equation number 1, 2 and 3, from all this equation, what you can do is half of area of ABCD will be equals to half of area of PBQR. So area of PBQR will be equals to area of ABCD. This way you can prove. Now question number 10 you have to do, 11 also you have to do. Also you can do, only we have to show the situation is given to you and according to solution you have to solve. Then 13 also, 13 is easy for you only. 14 is also easy, that is based on trapezium, properties of trapezium. See, in this you are having same parallels and same base, so all the areas of the triangles will be equal. Then after you have to add the triangle, then again that 15 will be same, and all the sums 16 is also same. So I am not doing other sums. Now if you are having any doubts, you can ask to me in lecture.